Sparrow is a mathematical representation of nature. It's a model. Most models are that. They are just a representation of dominant features in nature, not of every single detail, but of the big features that explain, certain phenomenon. In this case, how does water get polluted by nutrients? That's the big picture feature that that this model is trying to represent.
SPARROW is one of many watershed models that describe the sources and transport of a constituent. In this case, we're talking about nutrients, nitrogen and phosphorus, to rivers and streams, and then their transport on to downstream receiving waters. And SPARROW is an acronym for spatially referenced regression on watershed attributes. So SPARROW is a regression model. Its approach is to explain the pattern of stream loads of nitrogen and phosphorus, and to explain them as a function of geographic characteristics of the watershed. So it's really driven by, unlike other watershed models, which tend to be driven by rainfall, SPARROW is driven by the spatial pattern of geographic features.
What I've been talking about lately is about the two modes that SPARROW can be employed in, an empirical mode and a predictor mode. And so SPARROW is a coming together of two ways of looking at information. One way is primarily through deductive reasoning. We assume certain things about how contaminants transport and accumulate in the landscape, and that's built into SPARROW through the mass balance equation, through the way that we expect landscape features and stream features to affect sources. So that's the process-based information contained in SPARROW, but you have this other portion of SPARROW that is empirical. The model estimation and the information that you can derive from model estimation allows you to regionally test information in an empirical way, and that definitely sets SPARROW apart.
Nothing is really set in stone before you begin modeling. You don't have to make any a priori assumptions and go with them, except for some very basic structural equations. But as you are developing the model, you are trying and then setting aside, based on model findings, what the dominant sources are and what the dominant processes are. Wouldn't you see that as a strength, that you're not stuck with any assumptions? Like, if, for example, the model tells you that that urban areas, as much as we might think that they might be a source of phosphorus, we're really letting the model tell us whether that's true or not, just based on, and it's simply based on comparing the spatial pattern of urban land areas to the spatial pattern of in-stream
loads,
levels of phosphorus.
I agree with that, and the model also tells us whether or not the information we derive from the model could also be a statement about the quality of the input data. So even though we know that perhaps this variable should really explain, or we really expect it to explain, in-stream load variability, we just don't have good enough data, and that's a whole other a whole other bit of information. Just a lot of people talk about quality of data, what we can gather at a regional or landscape level is really coarse. So SPARROW definitely is a tool to highlight where we need better and more resolute information.
Mm-hmm.